Welcome to the walkthrough for the frequently made mistakes in assignment 1A. First and foremost, always make sure you run the unit tests that are supplied with the project. Many of the mistakes below would easily have been caught had you run the unit tests, inspected the output, fixed the problems, and/or come to office hours to get help with your code. Speaking of code, make sure you comment your code thoroughly. Don't rely on my specifications as the comments. You need to actually comment what it is you're doing and what it is you think your code is intending to perform. Another important thing to note, do not remove the to-do comments under any circumstances. I use those to-do comments to search quickly through your code to figure out what to review. So if you remove them, it makes things much more tedious. So do not do that. Let's now start looking through the various mistakes people made. Here's an interesting mistake. This code is calling create and start waiter for being threads, which returns a thread, and then it's calling start on the thread that's returned, which of course is going to end up with a very strange behavior because start will be called twice because the create and start waiter for being threads method is already calling start if it's implemented correctly. Down here we have sort of the opposite problem. This code calls create and start for waiter for being threads, but doesn't actually store the result anywhere. So as a result, down here, the code calls a wait, which makes absolutely no sense whatsoever. This code is supposed to be calling join on the thread object returned from the create and start waiter for being threads method. So please make sure you fix that and avoid that type of problem. Here's an interesting situation. This person had a belt and suspenders approach to memory allocation where they first allocate mbeing threads with a new array list and then go and use the streams framework to collect the results into mbeing threads. You don't need to do both these things. In fact, this is the right thing to do. Just do that. So make sure you don't have duplicate initializations. You're just wasting memory. This particular code also made no sense because it created an uncaught exception handler, but then I can't even really tell what it was doing, but it wasn't doing what it's supposed to be doing. It's supposed to be connecting this to each of the threads that are created here as part of the initialization of the mbeing threads or list. Down here, we see some problems with begin being threads. There's lots of problems with begin being threads people do. First of all, make sure that you use the right syntax. Don't just say new array list and not add in the diamond operator, which says to make something that's appropriately typed as opposed to being just an array list of objects. Avoid using m as a prefix for local variables. They're really only supposed to be used as a prefix for fields. So get in the habit of doing that. M is just there to indicate it's a member. That's a field in a class. This code makes no sense at all. What's supposed to be happening here is this code is supposed to be passing in the runnable as the constructor to thread, or as a parameter to the constructor to thread, and not just doing this code. This code makes no sense whatsoever. So please don't do this. Down here, please get in the habit of using a method reference and the for each method as opposed to using for each loops wherever you can. So that's a good habit to get into. Let's take a look at another problem with begin being threads. Please make sure that you use method references instead of lambda expressions. Your IDE, the Android Studio IDE, should automatically prompt you to make that transition, to switch from one to the other. It'll actually do it for you. You just have to tell it that you want it to do that. Down here, this code can be improved by changing the type here. Instead of being, it should be simple being runnable. And if you do that, then you don't have to go ahead and cast the GB variable into a runnable. It'll already be a runnable because simple being runnable implements runnable. Let's go take a look at another problem with begin being threads. This is another example of where you should be using method references, more specifically constructor references. If you have any questions about constructor reference, please don't hesitate to come to office hours or post it on Piazza after looking it up on Google. Now here's a problem a number of people made, and it kind of frustrated me because I explicitly mentioned this in class when we talked about passing code to a thread to give it code to run. Never, 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 never create a Java thread without giving it a parameter to its constructor to provide code for the thread to run when it starts. This code makes absolutely no sense. This mistake would have been caught had the unit test been run and had you inspected it carefully to see what it was yelling about. Down here, notice the comment says start running the thread. This code is not starting the thread, it's running the thread, which is not, it's not even running the thread, it's just calling the run hook method on some object T. This actually probably should be thread run. But whatever the case is, do not do this. This makes no sense. Read the specification here to see what you need to do. Down here, here's an example of making the code way more complicated than it needs to be. Try to avoid the habit of writing range-based for loops where you have, or sorry, index-based for loops where you have to walk through the for loop one element at a time, starting at 0. That's very, very, very bad style nowadays. You should be using either for each loops or the for each method here. Probably want to use a for each loop. That's pretty straightforward with the appropriate try catch blocks and so on. Down here, please avoid the use of anonymous inner classes. Use lambda expressions, much cleaner, way less syntax, less chance of getting carpal tunnel syndrome, so stay away from that. Let's now move into the simple being runnable class and see some common problems that occurred here. First and foremost, make sure you move the acquire method, the acquire Palantir call outside of the try block, and make sure you always release the Palantir even if an exception is thrown in gaze. This code will not do this. If gaze throws an exception, release Palantir will be skipped. And we talked about this in class. I posted a link to Piazza on how to address this very issue. And the hint is to learn how to use try catch blocks, or sorry, try finally blocks. You actually, speaking of try catch, you actually do not need to have a catch clause in this method. If you're getting null pointer exceptions, something is very wrong. So you need to be careful. That's why this code should go out of the loop, and you should explicitly check to see if you get back a null. You should not be dereferencing a null pointer. That's evil, evil, evil. So get out of the habit of doing that. And throwing an illegal state exception doesn't make any sense. That doesn't tell anything useful. So those are some of the common mistakes I saw. I'm sure there are other mistakes too, but these are the ones I saw most frequently occurring. So take a look at my comments. If you didn't submit your program correctly, this is the best thing you'll get as far as the feedback I'll give you. So take a look at the frequently made mistake review here, and then go look through your code to see if you made any of these mistakes. And if you did, then make sure you fix them before the assignment 1B release comes out here shortly.